Hello, welcome to ATI 4640. In this session, we will continue addressing human resources, job design, and work measurements. We will focus on how methods analysis is used to analyze tasks to understand how a task is accomplished. Um, Charts and diagrams will be used to describe the movement of material, information, and people. We can describe the activities and interactions between humans and machines. As we stated in the methods, analysis focuses on how task is performed. It's used to analyze the movement of people, material, information, and in some cases, transactions in a task. The movement will be depicted using a flow diagram and a process chart. We can also use methods analysis to analyze activities of human and machines, human interactions, and team activities, which can be done through activity chart. The analysis can be can provide details even for body movement through what is called an operations chart. The flow diagram in this slide represents the movement of material in an auto part factory. This is the old workflow and was used to understand the movement and how to improve the process. Notice that incoming material has to be stored in bins until machine 1 is available. In the new flow diagram, it requires less storage space, as you can see, reduced the number of operators and created an efficient flow of material to the next station. This slide shows the process chart which was discussed before, showing the different symbols used to operate, transport, inspect, delay, and store. The process chart will show the distance in feet between the different stations or machines. It shows the number of minutes required for each operation. It shows also that the process or job has been designed with no delays and with minimum storage time. In addition, Pokayoke has been placed to inspect welding without any delays. And as we stated before, the Pokayoke is like a failure detection in the process, which will assist in like a foolproof detection, and it will assist in the inspection and making sure that no errors or no mistakes will happen in the process. This slide shows an activity chart for an oil change process. It's a two-person crew type of a job with specific list of tasks for each operator that is timed to ensure that he or she or the whole process will not take more than 12 minutes. After 12 minutes, the process will be repeated. The operation chart in this slide analyzes the body movement of a worker scooping ice for a coffee machine at Starbucks. It's designed to identify wasted motion and idle time. From the chart, you can see that the left hand completes 2 operations while the right hand completes 3 operations. The left hand will be transporting one time and the right hand will be transporting another time. The left hand will have four delays while the right hand will have 3 delays. This chart will assist also in the training process to make sure of the consistency and the quality of the work and services that will be provided by the employees. All employees will be trained the same, so the movement of the hand will be the same for all employees. The virtual workplace uses color-coded cards, labels, wires, lights, and other low-cost visual devices to share information quickly and accurately. It can replace printouts and paperwork. When you give somebody a paper, they have to read it to know exactly what to do. While if you have labels and if you have lights that will indicate red for attention, or you need to pay attention for that, or alert, green is go, that will be easier to understand. Since there are lots of changes in the workplace, it can provide timely information in such dynamic environment. The visual workplace will assist in eliminating non-value added activities. Visual instructions can reduce the need for supervision. The visual signals in the workplace can present the big picture and increase performance. In addition, it can serve as housekeeping list to finish some routine housekeeping tasks. This slide and the next two slides shows some examples of visual signals and tools that will help in the workplace. We can also use visual utensils that will hold or encourage in the organization and proper housekeeping. This also we have here in the slide 3-minute timer that serve as a reminder to the employees goal, so they make sure that the goal of 3 minutes, then I need to finish within those 3 minutes. And again, this is to remind the employees of their goal so they can finish within the proper time or the given time. Other visual signals can be put at the machine to notify support personnel of line of machine stoppage by lighting red, or if a maintenance needed by lighting yellow, or if all is good by lighting green. Visual and colored indicators can also be used in inventory control and define the threshold of reordering based on the number of units available in the inventory system. We can use bins to indicate ongoing daily requirements based on the quantities in each bin, and clipboards that provide information on schedule changes. Also, a board can be used to post the company data, process specifications, and operating procedures for each work area. To plan for finding the resources required to complete the tasks, managers should have the knowledge on what kind of skills should the workforce have. Actually, companies will have standards for the amount of time required to perform a job or part of the job. When the company has the correct standards in place, it will help determining the skills, how the job should be completed, the cost associated, and what will be considered as fair work. The labor standards started early in the 20th century. A large proportion of the work was manual, but little was known about what can be considered a fair day of work. Establishing the standards is important to both manufacturing and service organization. Actually, it's necessary for determining staffing requirements. Using the standards as an incentive or standards, we can create an incentive system that can be used to award people working who will meet and exceed the requirements, and that will motivate other people who just started in the system to thrive and advance to reach to that award or that level of awards. Meaningful standards will help determine a description of the job and what needs to be done, the number of people required to accomplish the job, the cost of labor associated with each job, and estimated or expected duration of each task. If the job needs or need to be done in teams, then the team size will be determined and the work will be distributed to ensure work balance. Knowing duration and the number of people assigned, we can estimate the number of units produced within a unit of time. It can determine the basis of wage incentive plans. It can determine and help in calculating the efficiency of employees and the efficiency of the system. How do we set labor standards? There are four ways which can be used individually or through integration, two or more ways to create and determine these standards. We can use historical data and experience, time studies, predetermined time standards, and or work sampling. And again, we can use either one of them or we can integrate two or more of these ways to determine those standards. The historical data or historical experience will inform us how the task was performed last time, what method was used, what tools, what techniques, was it easy or hard, was it cheap or expensive. We can use data also available for or from production records or time cards. The data should be verified and validated to ensure accuracy. It can be cleaned and outliers can be deleted. Missing data should be treated, and then inaccurate data will not be recommended to be used in these situations. Time studies involved timing a sample of workers' performance and using that to set standard. So we monitor the employee doing some sort of a job, we time them, and we set that as a standard. Now, we cannot monitor only one employee. So we need to monitor more than one employee, more than one time, and then use the data to find the timing for that job. So if there was variability in completing the job by different workers, then other factors have to be considered to determine which one should be used as standard. Sometimes completing the job with minimum time could affect quality. Based on that, other factors will be considered and the best timing will be selected. If the variability was within a small range, the average time can be taken or used. We monitor many employees in many situations, many different scenarios, and then we can see if they are doing the same job at the same time. If the variability is small, then we just take the average of that time, whatever the average is, and that will be our standard. To be able to perform such a study and judge the time you need, an experienced observer should be used. A trained and experienced person can establish a standard by following the steps in this slide and the following two slides. That experienced person will follow certain steps to judge and to find the proper time. It's not any person who can study the time and can perform or find the standard for the job timing. That person, they have first to define the task to be studied, which task is that, and then divide that task into precise elements, decide how many times to measure the task, time and record element times and rating of performance. Then to calculate the average observed time, we divide the sum of times recorded to perform each element by the number of observations, as many observations as we need, and then we use the performance rating to adjust the average observed time to what a trained worker could expect to accomplish working at a normal pace. A performance factor of 1.05 would indicate that the observed worker performs the task slightly faster than average. Multiplying that with the average observed time will provide the normal time or will adjust to a normal time. Then we add the normal time for each element to develop the total normal time for the task. To compute the standard time of the task, we divide the total normal time by 1 minus the allowance factor, which is a factor that allows for personal needs such as restrooms, using the restroom, using the water fountain, or unavoidable delays or worker fatigue. The allowance factor can be in the range of 4 to 7%, about 4 to 7%. The percentage will be based on the location of the restrooms, workers' lounge, water fountain, and other needs from the location of the task. And again, it differs from one company to another. Other companies can use a higher percentage just to assume the worst case scenario. The delays will be based on actual delays that occur, such as waiting for maintenance parts to arrive. Since you are waiting for those maintenance parts, then that will be a time that's wasted, and we have to consider that time just to make sure that the timing is included with those delays. And then the fatigue will be based on our knowledge of human energy expenditure. The table in this slide shows constant and variable allowances. So for example, for the personal allowance is 5%, the basic fatigue allowance is 4%. There are variable allowances such as standing allowance is 2%, abnormal position, awkward bending is 2%, very awkward laying or stretching is 7%, and so on. So we have the table in this slide that shows the allowance factor for the use of force or muscular energy in lifting, pulling, pushing, different ways in pounds. And the table on this slide shows allowance factor for the bad light and the noise level. The example in this slide is for a time study, and we need to calculate the normal and standard time given the average observed time as 4 minutes, the worker rating of 85%, and allowance factor of 13%. And see, this is what I was talking about, which is, it depends on the company. Some companies do not go with the range of 4 to 7%. They can increase that factor to give their employees more allowance to do the personal stuff or for the delays from parts. So the normal time will equal the average observed time multiplied by the rating factor, that's 4 times 0.85, which will equal 3.4 minutes. The standard time will equal the normal time divided by 1 minus allowance factor, and that is 3.4 divided by 1 minus 0.13, which will equal 3.9 minutes. So the standard time is 3.9 minutes for that task. In this example, the allowance factor is 15%, and the job in the place of study has 3 elements composing and typing a letter, typing envelope, address, then stuff, stamp, seal, and sort envelopes. Those are the 3 components. Looking at the observation, we can identify unusual or unnormal readings marked by asterisk. Those observations will be deleted since they are far from other reading. If you see the compose and type letter, and you can see that the observation was 8 minutes, 10 minutes, 9 minutes, and 11 minutes, and then all of a sudden there is a 21 minute, which is way out of range, then that might be an error and should not be used. That's why we delete that one, or we take it out of our calculation. And this is what we are talking about. We were talking about those outliers, those numbers that does not match, and we were talking about missing data where it should be treated, and then we can use the average, or we can use our calculations. The average time for each element will be calculated as indicated in the slide. Then we move on to compute the normal and the standard time. If you look again, you can see that average time for A, for component or element A, it will equal only 4 observation, and that's why we divided by 4. So we have the 8 plus 10 plus 9 plus 11 divided by 4, and the average time was 9.5, which is again within the range. Using 21 would skew the data or the information, and it will not be the same timing, and that's why it was taken out. The same for the stuff, stamp, seal, and sort envelopes. We have 5 that is considered as an outlier, so we took it out and we used the 2 plus 1 plus 2 plus 1 divided by 4, which will equal to 1.5 minutes, again within the range of the timing for that element. To compute the normal time, we multiply the average observed time for each element with the given rating factor of each element. We add the normal time of the elements to find the total normal time of the task. Those are the numbers for each task, for each element. To add and find it for the whole task, we add those numbers, and we will get the normal time for the total normal time for the task is 15.36 minutes. The last step, we compute the standard time for the job using the total normal time and the given allowance factor. The standard time will be equal to 18.07 minutes, and again we gave them more time. It was 15, as you can see from the previous slide, it was 15.36, but we need to give them more allowance so they can do the personal stuff or consider delays, and that's how we got the 18.07 minutes for that task as standard. So the timing for that task is 18.07. And this is one of the things that we need to learn or understand, is how to find the duration of that task. Just to find the duration of a task is not, it doesn't come like that. It comes from experience, it comes from historical data, from finding the average, from computing and adding allowance factor, and finding the standard time. And once we have the standard time, that standard time can be used in our calculation, or can be used as standard time for the employee to do their job. In the previous example, we used 4 observation, but how do we determine the sample size and how many observations should be recorded so we say that it's accurate? So the sample size, the number of observation, is very important. For that, the sample size will be based on how accurate we want the results to be and the desired level of confidence we need. In addition, it will be based on how much variation exists within the job elements. The previous factors can be determined as used to calculate the required sample size through use of the formula in this slide. The required sample size will equal the number of standard deviations required for the desired level of confidence multiplied by the standard deviation of the initial sample divided by accuracy level desired in percent of the job element expressed as a decimal multiplied by the mean of the initial sample, all squared. The z-value will change in accordance to the desired level of confidence as shown in the table. The example in this slide will be calculating the sample size required to observe a task at Andy Johnson Manufacturing Company in Orlando with a desired accuracy of 5%, confidence level of 95%, sample size or sample standard deviation is 1, the sample mean is 3, which means that H is 0.05, X bar is 3, S is 1, Z is 1.96 from the table in the previous slide. So using the formula and calculating using those numbers, substituting with those numbers, then N will be around 171 observations. So I need 171 observations to make sure that I met the accuracy that I need with the confidence level that I need. 171 observations. I need to time, sit, watch, monitor, and time those employees doing the job for 171 times, and then take the average or calculations based on the formula. If desired accuracy H is expressed as an absolute amount, we substitute E for H X bar, where E is the absolute value or absolute amount of acceptable error. The formula will be N equal to ZS divided by E all squared. When the standard deviation is not provided, it must be computed. S will equal the square root of the summation of xi minus x bar squared divided by n minus 1, where xi is the value of each observation and x bar is the mean of the observations, and n is the number of observations in the sample. The third way of determining task time standard is to use a predetermined time standard. Something that's been predetermined before, or somebody did before, and it's predetermined that this is how long or how much time you need to accomplish this task, where we divide the manual work into small basic elements that have established time. Those times can be determined in a lab or lab environment, or outside the job, away from the actual production operation, which can be set before the work is actually performed. In this approach, no performance ratings are necessary, and worker unions tend to accept those calculations or those standards. The most common predetermined time standard is the methods time measurement, or MTM, which is a product of the MTM association. The MTM can document common activities such as select, grab, position, assemble, reach, hold, rest, and inspect. The figure in this slide shows the set of time standards for the motion, get, and place. The MTM table document the weight of was gotten and how far was moved. The example in this slide will be using a predetermined time measurement to determine the standard time in a general hospital. The data in the table can be used to develop standard times. The task will be a pouring tube specimen. There are 5 elements involved in this task. A technician removes the sample tube from the rack, uncaps that, gets the centrifuge tube, pours, and places both tubes in the rack. Weight is less than 2 pounds. Conditions of get is easy. Place accuracy is approximate. The distance range from 8 to 20 inches. So the MTM element of the get activity AA2 based on the table in the previous slide equal 35 TMU or time measurement units. That is a code of AA, and the column 2 same applies for the rest of the elements. And for that we can replace all the codes for the elements with the time in the time measurements unit, and as a result the total of the TMUs for the task elements will equal to 238 TMU. The TMU as a measure is equal to 0.0006 minutes. So we can convert the 238 by multiplying that by 0.0006, which will equal to 0.143 minutes, or around 8.6 seconds. So the task will take about 8.6 seconds. The last method that we can use to do standard is called work sampling. Work sampling estimates percentage of the time a worker spends on various tasks. It requires random observation to record worker activity. The results are used to determine how employees allocate their time. The knowledge extracted from the results can be used to set staffing levels, reassign duties, estimate cost, and set delay allowance. The work sampling procedure can be summarized in 5 steps. Take a preliminary sample to obtain estimates of parameters value, compute the sample size required, prepare a schedule for random observations at appropriate times, observe and record work activities or worker activities, determine how workers spend their time. To compute the sample size, we use the following formula. Sample size will equal the standard normal deviate for desired confidence level squared multiplied by estimated value of a sample proportion multiplied by 1 minus estimated value of the sample proportion, all divided by the acceptable error level in percent squared. In this example, the manager would like to determine the sample size to measure employee idle time. Estimates the estimated employee idle time is 25% of the time. Sample should be accurate within 3 plus minus 3%. Want to have like a 95.45 confidence in the results. So using the z value for the 95.45, z will equal to 2. The number of observation, once we substitute all the values that we have with the 25%, the plus and minus 3%, and the confidence with z equal to 2, we will find the number of observation, which is 833 observations. The same manager from the last example would like to make sure that the company's employees have adequate time to provide prompt, helpful service. The manager would like the target of availability to be within 25%, as we mentioned in the last slide. So the observations were 833 within 2 weeks, covering different activities. The table in this slide shows the number of observations covering each activity. All but idle and personal time are work related. So we have the personal time and the idle time is not work related, but the other 3 are work related. The percentage of idle time is equal to 126 plus 62 divided by 833, and that will equal to 22.6%. Since this is less than the target value, which is 25%, then the workload needs to be adjusted. And this is how we do it. We look at the target, which is 25%, and if we didn't meet that target, then we need to readjust and balance the workload in a way to meet our target. The focus of the work sampling is to determine how workers allocate their time among various activities, which will be accomplished by establishing the percentage of time individuals spend on these activities rather than the exact amount on specific task. The analyst records these percentages through random sampling. The figure in this slide and the next slide shows work sampling time studied or studies done to determine what salesperson do at a wholesale electronic distributor. And this figure shows the work sampling time studies done to determine what composite of several auto assembly line employees do. Work sampling is less expensive than time study. Observers um, need little training. Studies can be delayed or interrupted with little impact on results. Worker has little chance to affect results and it's less intrusive. Now remember with the time study, we need a specialized, trained, very well trained, skilled observer to observe and make sure they are taking the right timing, and then there are factors that will be affecting the observations that expert will be taking. But it's not as detailed as time study. So the time study is more detailed. That's why work sampling can yield biased results if observer does not follow random pattern. If they didn't choose randomly, then work sampling will be biased in the results. And it's less accurate, especially when job element times are very short. Some of the factors that should be considered when designing a job: fairness, um, equity, and ethics. So we need to make sure that when we design the job to make it fair, we need equity and ethics. Other important issues may relate to equal opportunity, equal pay for equal work, and safe working conditions. It will be helpful to work with governmental agencies or unions, trade associations, insurers, and employees to make sure that we have those ethics, those standards, those opportunities available for everybody. So it's more of like teamwork to establish those standards to make sure that we are giving everybody the equal opportunity, equal pay, and safe environment to work in the company. That will be all for this session. If you have any question, please feel free to ask. Thank you and have a great day.